For the equation y equals 1/2 x squared plus 2x minus 3, we're going to ultimately graph this equation by first answering some preliminary questions. In part A, determine if this parabola opens upward or downward. To answer whether this parabola opens upward or downward, we need to look at the leading term, and specifically the leading coefficient. Because the a value is a positive value, this parabola will open upward. In part B, to find the vertex, we use the formula to calculate the x-coordinate of the vertex, which is that x equals the opposite of b over 2a, or in this particular case, that x equals the opposite of 2 over 2 times a half. In the numerator, we end up with -2, and in the denominator, 2 times 1/2 is 1, and the fraction -2 over 1 is equal to -2. Now that we know the x-coordinate, we need to calculate the y-coordinate using the original equation. So y will equal 1/2 times the quantity -2 squared plus 2 times -2 minus 3. Order of operations, I'm going to take care of that square first. Since the negative is inside the parentheses with the 2, -2 squared is positive 4, so I get 1/2 times 4. I can take care of the multiplication in the middle. 2 times -2 is a -4. And then we have minus 3. Continuing the simplifying, 1/2 times 4 is 2. So we now have 2 minus 4 minus 3. And if we go one step further, 2 minus 4 minus 3 is -5. And so the vertex is the point -2, -5. In part C, we're going to create a table of values for this equation using the vertex to determine the x values that we will choose. So to create this table, we'll create an x column, a y column, and then an x comma y column. We'll put the vertex in the center of the table, so we know for an x value of -2, the y value is -5, and that gives us the ordered pair -2, -5. From that x value, we'll create two x values that are less than -2 and two x values that are greater than -2. So starting at -2, if I subtract 1, I would get -3. And from -3, if I subtract 1, I would get -4. On the other hand, if I start at -2 and I add 1, I would get -1. And if I add 1 more, I would get 0. So we're going to have 5 values in our table, but they're all centered right there on the vertex. So to calculate out these y values, we need a little bit more room. So I'll create some extra space here. And for each of those x values, we'll go ahead and work out what the y value is. So for x equal to -4, the y value is going to be 1/2 times -4 in parentheses squared plus 2 times -4 minus 3. -4 in parentheses squared is 16. 16 times a half is 8. In the middle, 2 times -4 is -8. And then we have the minus 3. So 8 minus 3 is -3. And that gives us the ordered pair, -4, -3. In a moment, I will transfer all these values back to that table. Now working with an x value of -3. The y value will be 1/2 times -3 in parentheses squared plus 2 times -3 minus 3. -3 quantity squared is 9, so we have 9 times a half, which is 4.5. 2 times -3 in the center is -6, and then we again have minus 3. 4.5 minus 6 minus 3.5 will give us -4.5. And so we have an ordered pair of -3, -4.5. We've already done the x value of 2 when we calculated the vertex, so we'll now move to an x value of -1. To find the y value, we substitute -1 in for every x, so we get y equals 1/2 times the quantity -1 squared plus 2 times -1 minus 3. -1 in parentheses squared is 1, times a half is 0.5. 2 times -1 is -2, and again we have minus 3. 0.5 minus 2 minus 3 is -4.5. And as an ordered pair, this would be -1, -4.5. And finally, our last x value in the table, x equals 0. Again, we will substitute 0 in for all of the x's, So we'll have y equals 1/2 times 0 squared plus 2 times 0 minus 3. The nice thing about using 0 as an x value is anything times 0 is 0. So 0 squared is 0 times 1/2 is 0. 2 times 0 is 0. Those first two terms are 0, so they basically disappear, and we're left with -3. So we have the ordered pair 0, -3. Now returning back to our table, we can fill in the y values that we just calculated. We had -4 as an x value, had a y value of -3, and an ordered pair was -4, -3. For -3 as an x value, it had a y value of -4.5, and so we had the ordered pair -3, -4.5. For an x value of -1, its y value was -4.5, and its point was -1, -4.5. And for 0, we had a y value of -3, giving us the ordered pair 0, -3. And finally, in part D, we need to graph this equation, so we're going to set up our axes, drawing them with a ruler, making sure we label them as x and y, and add arrows to at least the positive ends of the axes. And we need to set a scale on this graph. Now in the x direction, I'm going to use a scale of 1, 2, 3. And in the y direction, I'll also use a scale of 1, 2, 3. You'll notice that I've offset the center or the origin of the graph off to the upper right. The reason I did this is looking at these particular points, all of them have both -x and y values, and so I want to make sure there is room on our graph to plot all of those points easily enough. The first thing I'm going to plot is the vertex at -2, -1, 2, 3, 4, 5. And from there, I'm going to plot the other points. One point was at -1, -4.5. Another point was at 0, -3. On the left side, we had a point at -3, -4.5. And we had another point at -4, -3. In what we have now just plotted, there should be several things that are standing out. Number 1, since the vertex is either the highest or the lowest point, and all the other blue points are above it, this is matching with the answer to part A, that this parabola should be opening upward, and it does. The second thing that should stand out is because we use the vertex as the kind of center of our table, there should be symmetry between these points that we're now plotting. So the 2 points that are 1 x coordinate away from the vertex should be at the same height, and then the other 2 points that are 2 x values away from the vertex should also be at the same height, which they are. So not only do we have it opening upward, we do have the symmetry we would expect to see. So to finish, we will connect the dots in a nice smooth sort of way. We will not use a ruler to connect the points on a parabola. When we graph one of these by hand, we're not looking for a perfect graph, but something that hits the points that we're given and shows basic symmetry like we should be expecting to see.